One-step equations. On the pretest, you had a question that said, solve for b minus 76 equals 11. When we have a variable written in an equation, we can often solve for that variable to find out what it's worth. And that's what this question was asking you to figure out, is how much was b worth? Solving equations is a lot like solving puzzles. You can use visual strategies or you can use guess and check. There is also a strategy that involves canceling like terms that I'll show you in this video. It's important to show all steps of solving the equation because as the equations get more complex, there may be steps you have to complete. There may be many steps you have to complete to solve the equation. Now this video is going to include how to solve equations that include addition, subtraction, multiplication, and division. And it can get very kind of long, but make sure you watch the whole video and take note of where I address certain types of problems so you can come back to it and not have to watch the entire video next time. So let's take a look at a plus 45 equals 92. I'm going to begin with the visual strategy, and I'm going to use the number line that we've used on lots of different occasions. In this case, I know that my total has to equal 92. That's what I'm trying to get to. And I know that I have some amount, and if I add that amount to 45, I'm going to get all the way to 92. Now, I could have made these as all different little steps, little bumps to get up to 92, but I've decided I'm taking the two big chunks that I have to use to get to 92. So I could use kind of guess and check to figure out what does and doesn't equal 92. Maybe I want to try to substitute in 40 for A, and then if I add that to 45, I'm going to end up with 95. So I know I have to go, I'm sorry, I get 85. Oops. I'll have to attend to precision and back up there. So I know I have to go a little higher than 40. And if I go 50 plus 45, then I get 95. And that's too high. So I know I need to back off 3 from my 50 to get my 92. And so I know that I'm going to have to do 47 plus 45 gives me 92. So this would be using the visual model. I need 47 plus 45 to get to 92. And then over here, we use guess and check. There's another way to think about this problem. I'm going to begin by writing the problem out again. A plus 45 equals 92. And this structure or this pattern or this strategy is used most often in a lot of algebra classes. And it's the idea that if we have something on both sides of our equal sign, we need both of those sides to balance or to be equal. So if we have something on this side, like we have 45 over here, and I know I have at least 45 over here, it just happens to be inside my 92. And so if you have those values on both sides, you can cancel them out. You can cross them out. And so what we do is we take a look at what are we doing to A over here? Well, we're adding 45 to it. And so if I want to get rid of that over here, I'm going to subtract 45. And I have to do the same thing over here. And when I subtract 45 over here, I cancel those out and I'm left with A. And over here, I just have to perform the subtraction. When I perform that subtraction, I get 47. And so this method of canceling or taking out what we know to be on both sides helps us isolate or get the variable all by itself. And then we can calculate by using the opposite operation that was used over here to figure out our answer. So let's take a look at the next problem. Now I have b minus 76 equals 11. So if I'm going to start with a visual strategy, I'm going to begin by showing my number line. Now what's tricky is to think about what I'm actually doing on this number line. I'm actually taking and putting b out here because I'm subtracting 76 from that to get to 11. If I were to actually model what this problem is doing, this is what's happening. I'm going to actually put an arrow on here so I know I'm moving backwards. I'm starting at B and moving backwards 76 to get to 11. So that tells me that my actual B has got to be larger than 76 if I'm taking 76 from it and getting to 11. So I could try guess and check. I could try, like, I know if I do 80 minus 76, I would get 4. If I did 90 minus 76, I would get 14. And so I can figure out, well, this number is 3 too high. And so what if I tried 87? Subtract 76. Would that give me 11? Using the same strategy I used before, I can do B minus 76 equals 11. And so right now I'm taking a number and subtracting 76 from it. So if I want to try to keep this balance and cancel out my 76, I'm going to add 76 to both sides of the equation. So what I'm left with is B equaling 87. So my answers jive. I know that this B is worth 87, and that solves that equation. My multiplication equation might look a little different to you. It says 6C equals 42. And 6 times C, in this case, doesn't have a multiplication symbol, and it doesn't have a raised dot. We would expect to see 6 times C, but that gets confusing when we're doing algebra because that could be the variable x. We might be saying 6xc, which would be 6 times x times c. Another thing you'll see sometimes is a raised dot for multiplication. And so it would say 6 raised dot and c, and that would mean c. That would be multiplication as well. But in this case, we're just going to be using the 6c to represent 6 times c. So let's take and start with our number line. I know that I'm equaling 42, so I'm going to put 42 out here at the end of my number line. And then I'm trying to figure out how many jumps of 6 does it take to get to 42. You could also think of it as 6 jumps of how much does it take to get to 42. So I'm going to go ahead and put those 6 jumps out there. And then I'm figuring out the size of one of those jumps. So again, I could use guess and check. Like if I know that 6 times 10 is equal to 60, I know I'm going to have to do something smaller than that. If I do 6 times 8 is 48, because I happen to know that one. It's one of those facts I remember because it rhymes. And that's not going to work. So I'm going to try 6 times 7, and that helps me figure out that it's actually 6 times 7 is 42. If I were to use the same strategy that I've used before with canceling, I know that I have 6 of something over here and 6 of something over here, and I know that because they're equal. So I'm going to go ahead and divide each side by 6, and I'm going to use that fraction bar, which remember is also a division bar. So my 6's end up canceling over here. That leaves my c by itself. And then all I'm doing is 42 divided by 6, which is a fact that I should know. So c equals 7. And finally, we have a division problem. In this case, we're taking 10 and we are dividing it by d. And notice that we're using the fraction bar there rather than our usual division symbol. This is another thing they often will use in algebra. They'll set it up looking like a fraction with the fraction bar actually meaning division. So in this case, if I'm going to use a visual strategy, I know that I am ending at 10. That's my end point of my number line. And I have to figure out if I want to break it into 2 pieces, how big are those pieces? Or how many pieces am I breaking 10 into so they are the size of 2. So if I'm going to make jumps of 2, 4, 6, 8, 10, I can find out that those jumps of 2 take 5 jumps to get to 10. If we were to use guess and check, this one's such a recall fact that it's kind of difficult to do that. But you would just start setting up 10 divided by some number to try to figure out what would give you 2. And we know this one is a recall fact of 5. To use my same canceling strategy that I've used before, here I've got 10 divided by d equaling 2. We actually have an extra step involved with this. And so I wouldn't always recommend this strategy while you're first figuring out how to solve these problems. But in this case, I'm going to actually get this d over here, and then I'm going to solve by moving the 2 over here. So I would begin by multiplying each side by d. And then when I multiply by d, these d's cancel, and I'm left with 10 over here, and I'm left with 2d over here. And then I would go ahead and divide each side by 2. My 2's cancel over here, and I'm left with 5 equals d. So these strategies up here might be more of an efficient way to think about this problem, guess or check, or reasoning through using a visual model. But very often the ones that involved division might include the variable on top, which does simplify your process a little bit.